Hello and welcome to this first edition of The Daily Planet. I'm Julian Rush and I'll be here twice each day during the 4 days of this Planet Under Pressure conference. I'll be talking to some of the key scientists here at the Excel Centre in London, and we'll be bringing you reports from around the conference. We'll be keeping you up to date with all the latest news, the important announcements and of course all the latest science as we head towards Rio+20 in June. Coming up in the next half hour, we'll be taking a big picture look at the state of the planet. That's the theme of this first day, with two of the world's leading scientists who've been leading international efforts to get the world to wake up to the scale of the changes needed to make our future truly sustainable. That's Bob Watson and Will Steffen. And we'll be talking oceans and ice sheets, and we'll be discussing one of the key ideas in developing a sustainable future. That's the idea of planetary boundaries. But first, let's begin with the state of the planet. It's the theme of this first day at the conference, and to be frank, the news isn't good. I had the privilege to be a reporter at the Rio conference originally 20 years ago, and the messages that came out then are very much the same as the messages we're hearing today. Since then, there have been some changes, some actions have been taken, but nowhere near enough. And time is running out. Well, that was the message to the opening of the conference yesterday evening from Sir Bob Watson, who's the distinguished scientist who's the chief scientific advisor to the British government's Department of the Environment. Now, Bob, whose career spans NASA and the World Bank, amongst others, to his credit, has never been afraid of speaking his mind, to say it how it is. And he said as much last night as he delivered a message from the Blue Planet Laureates. That's a group of men and women who have won the Blue Planet Prize. It's an award for outstanding achievements in scientific research into solutions for global environmental problems. And I caught up with him after he'd spoken.
The message is we need to act now. It's urgent. We need to deal with issues of population, governance. We need to recognise that while we've had some action in the last 20 years from Rio, we've got a long way to go. We need to deal with climate change. We need to deal with biodiversity, food, water, energy, human security. Knowledge is important, but it's not a lack of knowledge which is stopping us acting today. If you'd say what are the two most important things, is getting the economics right and getting the governance structure right.
The problem is, though, that the world doesn't seem to be listening. What can you do to make the world listen?
I think we have to show and demonstrate that actually, and we've said it for years, if you don't look after the environment, it actually costs you economically. That there is no dichotomy between economic growth and a sustainable environmental system. We have to bring them together. That good economics leads to good environment, maintaining a good environment leads to good economics.
Yours is, I suppose, a call to arms, really, isn't it? You're calling for radical changes in the way that we run our societies. Is that a realistic thing to ask for?
I would say they're evolutionary. We need to transition to a low-carbon economy. We need to have a transition to complement GDP with these other forms of capital that the World Bank and others have been talking about for 20 years. So I wouldn't call it revolutionary, I would call it evolutionary. And the basic problem is if we don't get to grips with these issues, unfortunately, we will be undermining our long-term economic growth. We will not be able to get rid of poverty in the world today.
You keep talking about economics. Is economics the key to unlocking this whole issue?
I think it's very important. You could ask, why are we losing biodiversity? Most of biodiversity is not valued in the marketplace. We value the provisioning services of food, timber. We don't value the way our ecosystems protect our climate, our air quality, our water quality, storm surges, pollination services. So if we could actually start to value all of these services, I think we'd go a long, long way. We've got to recognise that when you burn coal, there are environmental and social costs. We need to internalise those prices into the real cost of coal. Suddenly renewable energy looks much more competitive. We need to pay our farmers payment for ecosystem services to reward them not only for producing food, but maintaining these ecosystems. So, and we need to get rid of these environmentally harmful subsidies in energy, transportation and agriculture.
But at the moment, anything to do with economics is kind of dealt with separately to anything to do with social issues or anything to do with environmental issues. How do you combine those three things so that all are taken into consideration at the same time? Which is what you're asking for, I think, isn't it?
It's what we're asking for. You've got to almost view the three pillars of sustainability as intertwined like a piece of DNA, basically, that you wouldn't think of a policy or a technology or a practice without simultaneously thinking about the economic, the social and the environmental implications. They've all got to be looked at together. We can't put the economy on one side and the environment on the other side.
It's an enormous challenge ahead, and in a word really, how big is the challenge ahead, and are you an optimist or a pessimist? Do you think that, say, by 2050 we will be living in a world that is more sustainable?
It is an immense challenge, but it's one we cannot fail on. We can't fail on because of the current society or our children or our grandchildren. I'm still an optimist, but we have largely wasted the last 20 years. We cannot afford to waste the next 5 to 10 years.
Well, with me now is one of the speakers who you've just heard in this morning's plenary session, Professor Will Steffen, who's the Executive Director of the Australian National University's Climate Change Institute. Will, welcome to the Daily Planet. You're talking today about what you call the Great Acceleration. What exactly does that mean?
Well, it means that there's really been an explosion of human activity since the Second World War. We were actually surprised to see this. It arose from a project we were doing to track from the beginning of the Industrial Revolution through to the present how human activity had changed and what were the consequences for the environment. So we started our graphs at 1750 and carried them through to 2000. What we saw when we actually plotted all this was all the graphs changed. They just went markedly up at 1950 or very close to it. Now, that really struck us. And when we looked at the consequences in terms of climate, in terms of ecosystems and so on, we also saw accelerating or increased rates of impact after 1950. So we just started using the term, this is a great acceleration in the human enterprise, in our relationship with the planet, in the consequences. So the term is sort of stuck after that.
Does that mean it's got to the point where it's too late?
Well, no, it doesn't. What it means is these very sharply increasing curves can't go on forever. And when you actually analyze biological systems that do this, they do one of a couple of things. One is they steady out and oscillate around a new state, or they overstretch their resources and collapse. So this is the point I was trying to make toward the end of my talk, is that I don't think it's quite too late, but we've squandered a couple of decades since we've had good scientific information. And in my view, this is the last decade we have to actually get it right.
We've got less than 10 years. You talked about tipping points quite a lot in your presentation. Some of them, I guess, are effectively completely irreversible in terms of humanity anyway, the ice sheets melting, and something that you raised which perhaps hasn't had as much importance, much coverage as others, and that's the issue of permafrost.
Yes.
What's the problem there?
Well, the problem is there's an enormous amount of carbon stored underground in the permafrost. To give you a handle on how big that is, it's about double the total amount of carbon in the atmosphere. So that's a lot. It's significant in terms of release of it, possible release of it to the atmosphere. That's been locked away very nicely since the last ice age, hasn't been activated during this present warm period. So we've sort of forgotten about it, out of sight, out of mind, not causing any problems. What we're starting to see, though, is as the planet warms, it's warming more in the northern high latitudes than the global average, about double. So that means they're getting more heat than we're feeling in the rest of the planet. We can start to see some melting of that permafrost, the upper layers of it, and there are some reports of sporadic gas emissions from that melting permafrost. Not enough to cause any problems yet, but it may be the early warning sign. So we've done a study to ask experts in the field, if we go to a strong warming scenario this century, how vulnerable is that carbon? And they've come up with some fairly remarkable numbers, which means there is a big risk there, that if we don't get the rate of warming down reasonably soon, we could face what we call a reinforcing or positive feedback. In other words, we'll get more emissions there that add to the emissions that we're creating.
Very briefly, scientists have traditionally been very reluctant to be forceful on things. They're always very aware of the caveats, the uncertainties around predictions. But I get a sense that's changing, that more and more scientists, like many of the scientists here, are beginning to say, look, it really is urgent. This is the way it is. Do you get that sense that scientists are finally coming out of their shells and beginning to shout and tell the world that the problem is really serious?
I think some are and some aren't. I think some scientists are tired of the bashing in the media by the deniers and so on. And so you see a sort of bifurcation here between some scientists who've gone back to doing their excellent research and others who are quite happy to talk about the risks. I like to frame it in terms of risk. There's a lot of uncertainty about the future. But I think we shouldn't be hesitant or reluctant to talk about the possibilities, the risks, the dangers that are out there, because that's how people can make informed decisions.
Will Steffen, thank you very much indeed for joining us. Now, we want you too to take part in the Daily Planet as well. You can, of course, as Nisha was saying, follow the whole conference on Twitter with the hashtag Planet2012, and of course we're on Facebook too. But you can have your say too. We want to hear from you. We want your thoughts, your comments, and above all, your questions for the guests here on the Daily Planet. And you can ask a question on our Facebook page, or we have a special Twitter hashtag for your questions, which is Ask Planet. Now, as well as the big plenary sessions every morning here at Planet Under Pressure, there's a whole lot else going on as well. Every afternoon, the 3,000 delegates break out into smaller groups to discuss the latest science, from climate change to economics, from the future of water, energy and food, to fairness, equity and poverty. An incredibly wide range of disciplines is present here, and they're all on a journey to come up with concrete, practical proposals for how we can make our future truly sustainable. One of the key areas where there's new science is the world's oceans. They play a crucial role in our climate, but they're also a key resource for humanity, from fishing to tourism. But they're under threat, and putting a value on that resource and knowing what might be lost as the oceans are changing as the climate changes is crucial. Well, I'm joined now by Dr. Carol Turley from the Plymouth Marine Lab here in Britain, and an expert in ocean acidification, and Professor Kevin Noone from the Swedish Secretariat for Environmental Earth Sciences, who's part of a new study just published called Valuing the Oceans, which he'll be talking about in a session this afternoon. Carol and Kevin, welcome to the Daily Planet.
Thank you. Thank you.
Carol, first of all, in summary, what are the major threats to the oceans?
The major global threats to the oceans are ocean warming, acidification, and, believe it or not, oxygen loss, deoxygenation. Acidification is because much of the CO2 that we're putting in the atmosphere is absorbed by the oceans. Already about 30% has been absorbed by the oceans. And CO2 is an acid gas, so we're adding acid to the waters, so the oceans are becoming more acidic. And that's impacting the whole carbon chemistry, or carbonate chemistry of the oceans. And the projections are that by the end of this century, much of the Arctic and the Antarctic will be corrosive to unprotected shelled marine organisms. Coral reefs may actually go past that point where they can increase calcification and growth of the reef, where growth is lower than the natural bioerosion, so they no longer accrete, in fact they're declining. And just like every other organism on Earth, like us, like you and I, we have to regulate our internal pH, our internal acidity. And we expend energy doing that. So it's not just the shell forming, but it's also the physiology of organisms that we're just beginning to explore over the last 5-6 years. So there's increasing investment in studying ocean acidification.
and the impacts, of course, could be dramatic. Those dramatic impacts, Kevin, how do you measure them? How do you put a value on them so that we appreciate and understand and get what we could lose?
Well, you can't put an economic price on much. So as our chief economist for the study said, you can put a price on whale watching, but it's difficult to put a meaningful price on whales. So what we did in this particular study is we could identify 5 categories of values about the oceans that we could actually put meaningful prices on, like tourism, like the value of the carbon sink that they provide for us, like the value of damages due to severe storms and sea level rise. So for those categories that we can put meaningful prices, what we tried to do was compare what would damage costs look like at the mid-century and at the end of the century if we went on a green trajectory into the future or a more or less business as usual trajectory. And the difference by the end of the century is about $1 trillion per year in terms of only those 5 categories that we could put meaningful prices on.
And what number did you come up with? What is the value?
Well, the difference in those two, being green or just continuing with what we're doing, assuming now that nothing seriously goes wrong on a business as usual trajectory into the future, is about $1 trillion per year. That's the difference. That's what we could save if we went on a low emissions scenario.
$1 trillion is a huge amount. Carol, is there anything that we can do about coming acidification, given the predictions for increasing carbon dioxide in the atmosphere, or is it too late? Are we going to have to learn to adapt to an acidified ocean?
Both. We've got oceans are warming because of the greenhouse effect, and oceans are acidifying because of the CO2. So the global solution is actually mitigating CO2 emissions, reducing CO2 emissions. But on a local and regional scale, there are things that we can do. We can reduce other sulfur gas emissions. We can protect the carbon stores, that marine carbon stores. We can look and see what kind of organisms might be able to adapt to this high CO2 ocean, and perhaps look for those for aquaculture and protein sources. And we can reduce other local sources of CO2, such as land inputs for CO2. So there are some local solutions, but and ways of thinking about adapting. But the real solution is reduced CO2 emissions. This little document, there's an exhibition stand here. It's Hot, Sour and Breathless, Oceans Under Stress, and it's a guide to these major drivers of ocean stress. So come and see our stand. It's on www.oceanunderstress.com, all one word, and pass the information on, because what we need to do is speak about oceans here. It's 96% of the living space of the planet, and it's getting about 5% of the attention.
Carol, excellent, thank you. And you got the plug in as well, which is
very
good. Kevin Noone, Carol Turley, thank you very much for coming to the Daily Planet.
Thank you.
Now, very much related to issues around oceans and sea level rise in particular is, of course, the way the world's ice sheets will behave as the climate warms up. This afternoon, there'll be a session to discuss new findings on the changes in polar ice sheets and glaciers and how they're responding to climate change. There'll be new results, both from field studies and from modelling. Now, in the forefront of much of the research into ice sheets has been, of course, the British Antarctic Survey. They're part of the Ice to Sea Consortium, a group of 24 research partners from 13 countries working to estimate as accurately as possible the future impacts of continental ice sheets on sea levels as they melt. Now, with me now is Dr. David Vaughan from the British Antarctic Survey. David, welcome. What is the latest research telling us about the future of the Antarctic and Greenland ice sheets?
First of all, it's worth remembering that even a decade ago we had no idea what was happening in Antarctica and Greenland. Now we have satellites up there that are measuring in several different ways that are beginning to agree with one another quite well what's happening to the ice sheets. We believe that both ice sheets are losing ice into the ocean, causing sea level rise. Greenland's probably got the nose at the moment and is losing more ice than Antarctica.
What sort of timescales are we talking about?
Well, sea level rise is one of those effects that just continues. It's not like temperature change, which might flip from one state to another quite quickly. For sea level rise, we have to look at an ongoing rise. At the moment, sea level's rising at 3 millimetres every year, but by the end of this century, it could be rising at perhaps several times that rate, and overall, we could have had somewhere between 30 centimetres and perhaps closer to a metre of sea level rise around the world.
But is there time for us to adapt, to move cities away from coasts? I mean, the requirements to adapt are considerable, aren't they?
Indeed, they are. And understanding the impact of sea level rise is about understanding the changing risk to these growing cities. Can we do anything about it? Well, of course, there are some cities that we can protect. We are sitting in London, and this is protected by a whole series of coastal defence measures. Sometime in this century, we'll need to improve those coastal defence measures, and to know how high to build them, we need to know what sea level is going to rise through the century and beyond. So it's about minimising risk. There are some coastal assets and some coastal cities that we'll find very much harder to protect because the costs would be prohibitive. For those that we need to at least inform the citizens what sea level rise is going to be.
Very briefly, is there any chance that there might be a sudden change? People talk quite often about tipping points. Is there a way that the ice sheets could tip and that the melting could accelerate?
Yeah, no, in a word. To raise sea level, we have to get either heat into the oceans to cause the sea to expand, or ice out of the ice sheets. And those are two processes that can really only happen at relatively limited rates. However, the impact of sea level rise comes instantaneously. It comes when we have that big storm surge that maybe happens only once every 30 or 40 or 50 years. But when it comes and there's been sea level rise, it may be that much more devastating.
David Vaughan, thank you very much indeed for coming in today. Now, as I said a little bit earlier, we do want you to take part in the Daily Planet as well. You can follow the whole of the conference on Twitter on the hashtag Planet2012, but we want your questions too, and we have a special hashtag for your questions, which is Ask Planet. Now, finally in the programme this morning, one of the key ideas in defining how the world can live sustainably into the future is that of planetary boundaries. It's the concept that there are a range of environmental, economic and social limits to the Earth. And it goes right back, of course, to a book I remember well, The Limits of Growth, published in 1972. Now, things have moved on a bit since then, and some of the dire predictions of that book have been proved to be false. But they've highlighted what is a real problem. How do you actually measure the planetary boundaries? Well, Professor Steve Running from the University of Montana in the United States is proposing today a new boundary that he believes can be measured. And Steve's with me now. Steve, first of all, very briefly, what are the planetary boundaries?
Well, the planetary boundaries as defined in the 2009 paper was an attempt to identify climate, ocean acidification, nitrogen loading, all these various system activities that we think are critical to the stability of the biosphere and that we can measure and we think have very high likelihood of spinning out of control if something isn't done.
What is the difficulty of measuring?
Well, the big difficulty is the global scale. It's easy to measure these attributes in a small plot, but to measure the entire planetary system, really before satellites, we couldn't do it all.
What does it mean in practice, living within planetary boundaries? How do you live within planetary boundaries?
Well, I think what we are on the cusp of is a collision between the theory of economics, where economic growth is what every economist imagines that is optimal, and ecological limits that, as you point out, the Limits to Growth book I read when I was an undergraduate, which was the first time we got a sense that there is, on a finite planet, some limit somewhere, and we better figure out how to measure that before it's too late.
Very briefly, what is your new idea, your new boundary that you think you can actually measure?
we have been measuring terrestrial primary production, which is simply the total plant growth of the whole land surface of the Earth. We've been measuring that by satellite since the year 2000. So we now have 12 years of record of plant growth every year worldwide.
Steve Running, thank you very much indeed for coming to the Daily Planet. Well, that's it for now from the Daily Planet. We're back in about an hour and a half with more, including an in-depth look at what this conference can feed into the Rio Plus 20 meeting in June, and the political challenges of persuading the world's government of the urgency of the need for action. So from me, it's goodbye for the moment, and I'll hand you back to Nisha Pillay for the next session of the plenary, which will begin in a minute or two.